Hi, Calculus 1 students. So this is the only example you have to watch in section 4.4, Absolute Extrema and Extreme Value Theorem. It is just a harder example of what you already know how to do. So what I would suggest you to do is to actually try this example yourself. Although I can tell you it's on the hard hand, okay? So most examples are actually easier than this one. So all right, let's do it. Okay, find the absolute extrema of this function on the interval from -12 to 15. I would like to remember that this was a past final question, fall 2014, so a while ago. That being said, as I mentioned, I took it because of its level of difficulty. All right, so the first thing to do is actually not very hard. It's just to take the derivative, okay? So remember, step number 1, take the derivative. But before taking the derivative, preparation step. So write this as like the inside to the power of 1/3. So f of x is going to be x minus 6 times 2x minus 3 to the power of 1/3. From there, taking the derivative is quite straightforward. F prime of x is going to be equal to 1 minus 6 times, and just as a quick reminder, we're using the chain rule here. So take the derivative of the outside. Okay. Then stick the inside in, step number 2. So this thing will be the inside. Or actually, yeah, let's keep the color code of green for this one. But the point is that you need to differentiate the inside. So the derivative of the inside here is going to be 2. All right, so that's the derivative. Now, let's simplify it a little bit, actually. So here, we have 6 over 3, that's 2. So we're going to have overall 1 minus 4 over 2x minus 3 to the power of 2/3. Okay, so that's our f prime of x. Now we're going to find the critical values, right? So we have 2 things to find out. We have to find where the derivative does not exist, which is fairly straightforward because it's only going to be when the denominator here is equal to 0. So f prime of x is equal to dne, okay? So that will happen when x is equal to 3/2. And it's going to happen because the denominator equals 0. Okay, so this denominator right here, well, which is also the overall denominator, but anytime you have a denominator that's evaluating to 0, you'll reach that conclusion. Then, okay, so we also have to solve f prime of x is equal to 0, and that's the harder part. Not that hard, but algebraically a little bit tedious, and there are things you need to be careful about. So here goes. You have 0, which is equal to 1 minus 4 over 2x minus 3 to the power of 2/3. And the first thing I'm going to do is I'm going to move this on the other side and cross multiply. So this will bring us to 4 being equal to 2x minus 3 to the power of 2/3. And now, here is where you need to be careful, okay? And I'll go slow at that point because this is where a lot of students are doing mistakes. So what I'm going to do is I'm going to write this as what it means. In other words, yeah, I'm going to write this as being, yeah, perfect. The cube root of 2x minus 3 squared, okay? You don't actually have to do this, but I do it so that you understand what's going on. The first thing you do is you take roots. In other words, the 2 solutions to this squared is equal to 4 are going to be negative and positive 2. okay? And that's the tricky part, okay? Because without realize, like, we have to be careful here that we are taking the two roots. Now, cubing both sides, you will keep the plus and minus, and you will have here plus or minus 8 is equal to 2x minus 3. And that brings you to two equations. So, okay, now I'm going to erase the first derivative. We're going to continue solving this here. So that brings you to two equations. Actually, I'm going to write them here. You either have that 2x minus 3 is equal to 8, or 2x minus 3 is equal to negative 8. And then solving them independently, you're getting, for instance, here 11 over 2. So x equals to 11 over 2. Or x that's equal to, here we have negative 5 over 2. Okay? Now, whenever you have critical values, it's very important to know which one are and which one are not in your interval. Like the interval is right here. And if you read them all, so let's underline all critical values. You have this one, and this one, and they are all in here. So they are all in the interval from negative 12 to 15. So what does it mean? Now I can erase this because I don't need it anymore. Remember that what we're doing to solve the problem is to punch in all the critical values inside the function. Okay, so I do need this critical value, so I'm going to write it down, let's say here. Okay, so x is equal to 3/2, just to be able to erase everything here. Oops. And then this is your step number 3, I guess, where you just replace all the values from bottom to top. So you have like f of negative 12. Then which one is next? The next one is this one, f of negative 5 over 2. Then f of 3 over 2, that's correct. Then f of 11 over 2. And finally, f of 15. So you've got to compute all of that. And then this is the function. Okay, so yeah, I'm actually going to write the skeleton of this function always. Okay, so there we are. I'm just copy paste for now. All right, so now we put the numbers in, right? So we're going to start with the negative 12. Okay, and this should be fairly simple to calculate. This is going to be negative 27. So the cube root will evaluate it to negative 3. So minus 6 times negative 3. So it's going to give positive 12, this one. And then obviously we move on, right? So negative 5 over 2. And then we have here negative 5 over 2. So you're going to evaluate this to negative 8. The cube root will give us negative 2. So negative 5 over 2 minus 6 times negative 2. Okay, so what does that give us? 12, so 24 over 2, minus 5 over 2. So that's going to give us 19 over 2. Okay, so for now, this is the maximum. 19 over 2, what is it? It is 9.5. Okay, so just to compare it with 12. Now 3 over 2. So all right, here. This one is probably the easiest because like this will evaluate to 0. So we simply get 3 over 2. And just to compare it with everything else, 1.5. So currently this is the minimum. Now 11 over 2, let's have a look. Okay. All right, so we're gonna have 11 over 2, and this will evaluate to 8. Cube root of is 2, so minus 6 times 2. Oh, we have a new minimum. So this is gonna be 12, 24 over 2. So as I can see, that's gonna give us negative 13 over 2, which is negative 6.5. Okay, so this is the new minimum. And for now, this is the maximum. Let's have a look at 15. 2 times, okay, so 15. Let's have a look. So we have 27. Yeah, 27 over here. Cube root of is evaluating to 3. So 15 minus 6 times 3. I should write probably the 2 here. Like, there you go. Same thing. So it's going to give negative 3. Not quite enough to be the minimum. So here we are. All right, and then obviously the highest value is the absolute max, and the lowest value is the absolute min. Okay, so absolute max so it's going to be the highest value, which is 12 of 12 at x equals negative 12, and the absolute value, the absolute min is right here at 11 over 2. So absolute min of negative 6.5 at x is equal to 11 over 2. Yep, all good. All right, I hope this helps. See you either in class or in the next video.